Frank, and today we're going to study multiplication of polynomials. Hopefully you've had a lot of concepts that I'm going to talk about today. So it's sort of like a review. It's 8 examples I have, all a little different, just to review some of the concepts that you've had. So if this is the first time you've seen this, this could be a little fast, but we're going to go very slow on the examples. But the idea here is to review you on some of the things that you've had. Okay, let's look at the first example. You have x raised to the second power times x raised to the third power times x raised to the fifth power. Now, they all have a common base, which is the x. And then there's 3 different exponents. So what do we do with the exponents? Now, in a previous video, I derived the laws of exponents. And that law for multiplication is that you just add the exponents. So you would say the 2 plus the 3, that's a 5, and 5 more is 10. So this answer is x to the 10th. And once again, if you would like to see this derived law on exponents, please watch one of my videos where I posted it as the derivation of the laws of exponents. And you can see how we derived each of the different 5 laws of exponents. But this is one of the ones we derived. So again, if it's the same base, x, you just add the exponents. 2 plus 3 is 5, and 5 is 10. Okay, that takes us to our second example. Now, what's different about this? There's coefficients in front of the variables that are not 1. This is a 3, and this is a -7. So we multiply 3 times -7, and remember a positive times a negative is a negative, and 3 times 7 would be your 21. And then again, we take the same base of x. You have x to the 4th times x to the 8th. The rule states that you add the exponents. 4 plus 8 is 12. So this problem is -21x to the 12th power. Okay? Moving to our third example. Our third example is when you have 2 variables. Now, you can have as many variables as is needed. However, you treat it the same way, but you got to look at the bases. Okay, notice you have 2 coefficients, -3 and -9. Now, a negative times a negative is a positive. You can put the positive, but it's understood to be a positive. If you put plus 27, it's fine, but without the sign, it's understood to be that 27, plus 27. Now let's look at the bases. You got a base A here and a base A there. Notice you got an exponent of 3 there, but you don't have an exponent written. But if it's not written, it's understood to be a 1. It's just not written there. So if you just say A, it has an exponent understood to be 1. So you add your 3 plus your 1, and get 4. Then you go to your exponent, your base of B. Base B. You got a B5 and a B5 again. So you add them, and 5 plus 5 is 10. So, now, we could add more variables, C's, D's, right on up to Z's or whatever if we wanted to. It's the same concept. It's not any more difficult, it's just longer problem. Okay? next example should have been taught, hopefully in some kind of Math 1, Algebra 1 sequence. You have a binomial, which is two terms, x plus 3, times another binomial, x minus 6. Now, I've seen this done a lot of ways. I usually ask the student if they've had it. Let's see how you've learned it. Okay, good. Some people call it an approach called FOIL. If you've heard that, you can use it. I've used it, but I really call mine double distribution. Distribute twice. It's the same thing. But students like the FOIL. They can remember that. It's a nice, easy pattern, but it's really distribution twice. So let's show you. Now, I like to run domes. The F stands for the first term in each one. Well, there's the first term, and there's the first term. So we write this little dome to let students see. Well, remember, these exponents are understood to be a 1 and a 1, and it's the same base, x and x. So the first term is x squared. Okay? Now, whether you use FOIL or distribution, the second term is the outsides, O. What it means is you multiply the two outside terms, So x times negative 6 is negative 18x. Okay. Now, we multiplied both of these terms by the x, so we've exhausted that. Now let's go to 3. The I stands for the inside two terms, the inside, the two inside terms, the 3 and the x, that's the I, inside. And 3 times x is 3x. And the L stands for the last term in the first one and the last term in the second one. So it's 3 times negative 6, which is negative 18. So, whether you like this approach of FOIL, a nice easy way to remember it, or you just distribute. Now, you don't want to leave it like this. It's not wrong, but it's not simplified, and most of the directions will say simplify. These are like terms. They're both x's. So if you got a negative 18 and a positive 3, remember the rule on addition of signed numbers or subtraction. You subtract the two numbers, 18 take away 3 is 15, and the dominant sign, the largest one, is the negative. So this would be 15, but it would be the negative 15. Now, foiling is going to be very useful. When you get into factoring, it's sort of going to reverse a FOIL. So please understand this concept. You'll get faster with practice, and you'll be surprised before you know it. You'll be going from here to there in your head with practice. Okay, so we go to our next example. It's the same thing, but the numbers are different. A little bit more to it. So you got a binomial, two terms, times two terms. A binomial times a binomial. So if you want to use the FOIL, or if you want to use just distribute, it makes no difference. But I'll write that out whether you want to use it or not. Okay, so what's the F stand for? The first term. Now, you got a coefficient of 3 and a coefficient of 2. So 3 times 2 is 6. You got an exponent understood to be a 1 here, an exponent understood to be a 1 here, and the rule in exponents, you add them, so 1 plus 1 is 2. That's your first term. Your O, go outside. Push your hands outside, that's the two terms. You got 3x times 9. So you got a 3 times a 9, which is a plus 27, and the x follows. Okay? DI stands for the inside two terms. So you go like this. Those two terms. So you got a negative 7 times a positive 2. A negative times a positive is a negative 14x. And your last term is the second one here and the second there. It would be these two. And a negative times a positive is a negative 63. Now, you're right, and let's simplify it. You got a 27, take away a 14, so you would subtract them and take the sign of the dominant one, the larger one, which is plus, and that would be 13x minus 63. And again, with practice, you're going to get faster, and believe me, with a lot of practice, you will be able to go from here to there in your head. Okay? Now, our next example is a question that students currently will make mistakes on. They try to do it too fast. Notice they see something squared, and they just want to square the terms individually. But if you remember what it means to square something, it means this. You multiply it by itself. That's what it means to square something. If I could get you to write that step down, then I'm quite sure you can get the answer right. So when you square something, a binomial, please write it down twice. Now let's FOIL it. You got your first. So you got a 2a times a 2a. Multiply the two coefficients. 2 times 2 is 4. This has an exponent of 1 understood. This has an exponent of 1 understood. So this one plus this one would be a to the second. DO, outsides. You got a coefficient of 2 times a coefficient of negative 3, which is a negative 6ab. Notice you got just one A and you just got one B. I, insides, it's these two. Okay, negative 3 times 2 is negative 6. Now, I encourage my students to be consistent. If they were to write BA, it's the same as AB. That's called the commutative property. You can reverse the order in multiplication. But I just have a rule. I say, look, if you call the first one AB, why don't you just write it in alphabetical order so you can keep intact. Even though the B looks first, why don't we do AB? Because when you have long problems drawn out, the last thing you want to do is collect the wrong terms. And that makes it easier to recognize AB, AB. And then your last would be these two. A negative 3 times a negative 3 is a positive 9b squared. Okay. Now, we collect like terms. Notice they're very easy to see. There's an AB term, there's an AB term. So we highlight them, and we got to put them together. So we have 4a squared. Now, if you owed someone $6, and then you owed another person $6, the owing is the negative, you would be 12 in debt. Well, in debt would be the minus 12AB. So the key to this problem, I feel, is for you to write that out twice. Okay, that leads us to our next two examples, and I'm going to erase this one I just did because I need to provide you enough room to do this problem. And I'm going to show you this a problem in two different approaches. One's called the horizontal approach, one's called the vertical approach. I would like to show it, both of them to you, and then you decide which one's better for you. Be good to know them both, but which one's better is one you would do. So I'm going to erase this one here that we just did. All right, now, when I first started out, I would put one up top and one over the bottom. So this is the first approach that I did when I was coming through. I put the first one up top, the longer one. And I think I got that concept, whether I was taught that or whether I just did it myself. Because when I was multiplying numbers coming up, if I had a number like 452 and I was going to multiply it by 27, I always put the bigger number at the top. That was me. So this is one way to do it. So let's look at this way first. Okay, so what do you do? 3x times 4x squared. 3 times 4 is 12. x1, let's put that there. And x2 is x3. That takes care of that one. 3x times 5x to the 1. 3 times 5 would be 15x squared. And then 3x times negative 8 would be negative 24x. So what we've just done is multiplied 3x times each of them. Now, let's deal with the negative 5. Negative 5 times 4x squared. To save you time, if you multiply these, you would get negative 20x squared. Put it under this square. Put it under that x squared and put your minus 20. And the reason for that is now they're lined up nicely for you to combine. Negative 5 times positive 5 would be negative 25x, and put that under this x. Raise it. They're lined up for you to combine. And negative 5 times negative 8 is a plus 40, and there's no numbers, constant terms, so you put plus 40. Now, this approach, they're all lined up. So you've got 12x cubed. Add these two. 15 take away 20 would be negative 5x squared. Negative 24 plus another negative 25 would be negative 49x plus 40. Now, that's the way I learned. But I've also know another way that I think the students really prefer. If I put them both up there, usually the second way is what the majority of my students have always liked, if I show them both ways. So let's look at that second way. You got 3x minus 5 times 4x squared plus 5x minus 8. Now, we could draw domes, but we don't have a whole lot of room there, so I'm just going to sort of guide you. What would happen if you distribute 3x times 4x squared? 3 times 4 would be 12x cubed. Okay? What would happen if you multiply this 3x times this 5x? Well, 3x times 5x is 15x squared. Let me get a better marker for you. Okay. Now, what would happen if we multiply this 3x times that negative 8? That would be negative 24x. Now, A lot of times when I now go to this -5, I would line them up just like I did before with the students. They would say, no, you don't need to do that, we can combine them. So we've taken this approach with them. Okay, if you don't want me to line them up, let's just go. What's -5 times this? -5 times 4x squared would be -20x squared. -5 times +5 is -25x. And then your constant terms, -5 times -8 is +40. Now, if you wanted, I could have lined these last three terms up under the appropriate one, but in the past, a lot of my students said, no, we can look at it now. How many cubes do you have? Just this one. Now let's look at the square terms. You have 15 of them, and you have -20 of them. Well, 15 take away 20 is -5x squared. Now let's look at the x terms. You have -24 of them and -25 of them. -24 plus a -25 is a -49x. And the only thing remains is our constant term of 40. Now, let's put a box around that and compare it with our first answer. They're both the same. So which one do you like? Well, one of the things I would suggest to my class is, look, try them both. Be able to do them both, but then favor the one you want. You know, you'll favor one of them. Again, it's up to you. All right, I hope that was clear. Now, as I did, I'm going to erase this one to show you the last one, which is the same concept. 2 terms times 3, but there's 2 variables. Okay? Now, to save our time, I don't want to make this too drawn out. I don't know which way you prefer better, but let's do it the way that my students at the end preferred. I'm going to do it the second way, because that seemed to be the one they liked better at the end. So what I'm going to do is leave it just the way it stands, and if I do it that way, I can don't have to erase that. Okay, so write the way it stands so we don't have to rewrite it in this approach. Let's go with it. What's 2a times 2a squared? Well, 2a times 2a squared. Remember, that's understood to be a 1. 1 plus 2, and that would be 4a cubed. Okay? What's 2a times -ab? Now be very careful. This is a positive and this is a -1. So a 2 times a -1 is a -2. You got an exponent of 1 and an exponent of 1, which adds up to 2. And then you have a remaining b to the first by itself. Okay. Last one. You have a 2a times a 5b squared. 2 times 5 is 10. You have 1a and 2b. Okay? Now, let's go with the -3b and let's run it underneath. Now, here's a suggestion. You're going to get a -6a squared b. You can write it over here, which we will, or you could write it right up under this one, which lines it up. That's your decision. But I'm going to put it over there, so you got a -3b times that. And remember, if you write it in the same order, alphabetical, it's easier to collect. You can see it quicker. So we're going to put the a squared first and the b second. Okay. Running this down, you got a -3 times a -1, which is a +3. You have A1 and B2. Okay? And then last, you got a -3b times a -5b squared. Let's write it here so it's not in the corner, which would be a 3b, which would be -15b cubed. That's the -3b times the 5b squared. Now let's look for like terms. We have one cubed term right here, a cubed, 4a cubed. Now let's look for the a squared b's. There's one, these two. So you have a -2 of them and a -6 of them, which combines to -8. Good. Now let's look for the a, b squared terms. There's 10 of them, and there's 3 of them. And 10 plus 3 is 13. And that leaves us the -15b. Now, multiplication of polynomials, you can make them longer. You could have 3 terms by 4 terms. You could have 5 terms by whatever, 6 terms. And that's what they are. They're longer. I don't know if they're any harder, but they're definitely longer. I hope you found this as a good review, and maybe you've learned something new. But I've also posted a few other multiplication videos online under my name, so you can look at them. But I hope this serves you well, and I'll see you next time.